Hey guys, welcome to Learn Today IGCSE. This video is a tutorial for Physics Paper 6 Variant 6-2 from February-March 2024 examinations. Question 1. A student determines the mass of a meter ruler by a balancing method. He is using the apparatus shown in figure 1.1. This meter ruler means that it has a 100 centimeter length, beginning 0 over here, and the end over here will be 100. The center, which is 50 centimeter mark, is here, and the load towards the pivot is a certain distance. Next, question A. The student places a circular load on the meter ruler shown in figure 1.2. Determine the distance of the center of the load from the zero end of the ruler as shown in figure 1.2. Figure 1.2 is not in scale. So we are looking to find the distance from the 0 centimeter mark to the center of the load. The diameter of the ruler is 2 centimeter, meaning that the center of the load is at the 28 centimeter mark. Question B, Part 1. The student adjusts the position of the meter ruler on the pivot until the meter ruler is as near as possible to being balanced. Describe a technique for ensuring that the ruler is as near as possible to being balanced. This experiment has also appeared in the May-June 2023 in Paper 6.1 and Paper 6.3. A technique to ensure that the ruler is as near as possible to being balanced is by moving the ruler, and the ruler just tips one way. Next, Part 2. The student finds that the ruler is as near as possible to being balanced when the pivot is at the 47.6 centimeter mark. Calculate the distance of the center of the load from the 50 centimeter mark as shown in figure 1.1. Use your value of d from part A and the equation A equals to 50 centimeters, take away d. The value of d from part A was 28 centimeters. So to look for A, it's 50 take away 28. So A will be 22 centimeters. Next, calculate the distance of the center of the load from the pivot as shown in figure 1.1. Calculate your value of d from part A and the equation B equals to position of pivot take away d. So the position of pivot is over here, and it's being mentioned that it's at the 47.6 centimeter mark. So to find B, it will be 19.6 centimeter. Question C. The student moves the load so that its center is above the 5 centimeter mark and balances the meter ruler. He repeats this procedure for the load at the 10 centimeter mark, 15 centimeter mark, 20 and 25 centimeter mark. His results are shown in table 1.1. So all the values of A and B has been plotted for us in table 1.1. Next, you are asked to plot a graph of A centimeter on y-axis against B centimeter on x-axis and use the values in table 1.1. You do not need to start your axis at the origin 0, 0. Draw the best fit straight line. When labeling the axis, don't forget to include your units. And now we can choose a scale for the x and y axis. On the y-axis, we are going to plot A. The minimum value starts at 25 centimeter up to 45 centimeters. And for x-axis, the minimum is 22.5 up to 40.5. We've got 4 boxes on the y-axis, and the difference between the minimum and maximum value is 20 centimeters. So if I divide it equally into 4 boxes, I will get 5 centimeter for each box. So I can start with the lowest scale of 25 centimeter, then add on 5 centimeter to 30 centimeters, 35, and so on. And as for the x-axis, we can start at 20 up till 45. The difference between the minimum and maximum value is 25 centimeter. And we've got 5 boxes on the x-axis. Dividing 25 with 5, we will get 5 centimeter for each box. So we can start at 20, adding up 5 centimeters would be 25, 30, and so on. And now we can plot the points from the table and draw the best fit straight line. For a best fit straight line, try to touch as many points as possible, and if you can't, you can always look for a few points below the line and a few points above the line. Next, Part 2. Determine the gradient G of the graph. Show clearly on the graph how you would obtain the necessary information. To obtain the gradient, you have to use the triangle method, which is firstly indicating the points that we're going to use. So I will be using this point and this point, and just draw a triangle connecting them. Identify the coordinates of your point. For me, it is 25, 28 and 40, 45. And then you're going to calculate the gradient by taking the difference of y-axis and divide it by the difference of x-axis. And you will get a gradient of 1.13. Many of you asked if your gradient should be in 2 or 3 significant figures. In your course specification, it has been mentioned that the calculation of gradient should be 2 or 3 significant figures. Both are acceptable. As for my answers here, I'm going to leave it as 3 significant figures. Next, question D. Calculate the mass of the meter ruler using this equation, where K equals to 25 gram and give an appropriate unit. The value of my gradient previously was 1.13, so minus 1. The value of M would be 187.5 grams. According to the marking schemes, a range of 150 to 350 is an acceptable answer, and the appropriate unit for this would be G as they're looking for mass. Next, question E. The accuracy of the result obtained by this procedure depends on the meter ruler without a load balancing with the pivot at the 50 centimeters mark. A student finds that this does not happen. She adds a small piece of modeling clay to one end of the meter ruler to correct it. Suggest if this is a suitable change for this experiment and explain your answer. By adding a clay on one side of the ruler, it's going to cause the ruler to tip one way and changes the mass of this ruler. So this is not a suitable change for this experiment. Next, question 2. A student investigates a circuit containing different combinations of the 3 resistors. She first uses circuit A shown in figure 2.1. In circuit A, the 3 resistors here are arranged as series, which is next to each other. You've got the power supply over here, an ammeter to measure the current, and a switch. Question A. Draw a voltmeter connected to measure the potential difference V for terminals P and Q. A voltmeter should always be connected across the components. Since we're looking to find the potential difference of terminal P and Q, we're going to extend the wire from P to Q and then place our voltmeter like this across the resistors. Next, question B. The student measures the potential difference for terminals P and Q and measures the current in the circuit. The meters are shown in figure 2.2 and figure 2.3. Read and record in the first line of table 2.1 the values of V and I shown in the meters in figure 2.2 and 3. Okay, so this V means it stands for the voltage, which is 3.1, and A is for ampere, the unit measurement of current. If this here is in the middle, it will be 0.1 and this should be 0.12. So the voltage is 3.1 and the current is 0.12. The unit measurement should be written over here. Voltage is in V, current is in A, and resistance is in ohm. Question part C. In circuit B, the student connects the resistors between P and Q as shown in figure 2.4. She measures and records in table 2.1 the values of V and I. And the same was repeated for circuit C. The difference between circuit C and B is that 2 of these resistors are connected in parallel and 1 in series. And for circuit C, all 3 resistors are connected in parallel. Part 1. Calculate and record in table 2.1 a resistance for each circuit. Use the values of V and I from table 2.1 and this equation, and then add units to the column headings. So we are being asked to fill up this part of the table whereby the resistance equal to voltage over current. This is the voltage and this is the current. For circuit A, it would be 3.1 over 0.12, which is 25.8. And you can repeat the steps for B and C. Next, question D, part 1. Calculate a resistance RA and use the value of R from circuit A and this equation. Okay, I'm going to place table 2.1 over here for easier calculation. So from circuit A, the R was 25.8. This value divided by 3 will give us 8.6. And to calculate resistance B, this is the formula. The value of R from circuit B is 13.2. So RB is 8.8. And calculate resistance C using this formula. The value of R from circuit C is 3.02. And RC would be 9.06. Since the value of RC is in 2 decimal place, I will add another 0 over here. Next, part 3. A student suggests that RA, RB, and RC should all be equal. State whether your results support this suggestion and justify your statement with reference to values from your results. So let's first find out How different are these values to each other? You can see that they're not much of a difference, but let's find out in percentage what are their differences. The percentage difference between these resistance are all lesser than 10%. Therefore, we can say that the suggestion that R, A, B, and C are all equal is indeed true. And for the justification, we need to support this suggestion with reference to values. So we can mention that the differences of each resistance to one another is only less than 10%. So always try to find out the percentage difference to answer this type of question. Next, question E. A student investigates the resistors in circuit A using a variable resistor to change the current in the circuit. Part 1. In the space below, draw the symbol for a variable resistor. These are all the electrical symbols that you must know before your exams. If you don't know them, please take a screenshot. The symbol for a variable resistor should look like this. Part 2. Suggest one advantage of using a variable resistor to change the current in the circuit. This question here is based on your knowledge from the theory, and the advantage to this is that it is easier to obtain a larger range of current, or we can easily set the current to a certain chosen values. A student determines the focal length of a converging lens by two methods. This question was also asked in the October-November 2023 paper in Planning and Investigation. So you can see that all the experiments are usually repeated, and practicing your past papers can really be helpful. Question A. The student sets up the apparatus as shown in figure 3.1. So the lamp and the lens is set up at a distance of U. The lens and the widescreen is being set up at distance V1. And the illuminated object is placed in front of the lamp over here. So the light is going to pass through the object through the lens, and it will be projected on the widescreen. Suggest one precaution that must be taken when setting up the apparatus to ensure accurate measurements. When performing this experiment, one of the things to take into consideration is that we have to ensure that the lamp, object, and lens is all placed at the same height. The lens and the screen has to be perpendicular to each other, and fix a meter ruler to the bench. They're only asking for one precaution, so you can pick any one of these three. Next, question B. The student sets the distance U between the illuminated object and the lens to 20 centimeters. He places the screen near the lens and moves the screen until a sharp image of the illuminated object is seen on the screen. Part 1. Describe a technique for obtaining an image that is as sharp as possible. To obtain an image which is sharp and clear, we can move the screen a little bit back and forth until you obtain a clear image being projected on the screen. Just like when you're taking a photo from your phone, sometimes we have to move our phone back and front to get a clearer image. Next, part 2. Measure V1, the distance from the lens to the screen, on figure 3.1. So to measure the distance of V1, we can just use a ruler, place the 0 cm mark at the center of the lens until the end of the widescreen, and for me I got 8 centimeters. So V1 should be 8 centimeters. Figure 3.1, drawn 1 out of 10th scale. Calculate V1, the actual distance from the lens to the screen. So the drawing that we see is 1 over 10th the actual scale, meaning that the actual distance would be 10 times larger, so 8 times 10 would be 80 centimeters. Next, question C. The shapes of the illuminated object and the image seen on the screen are shown full size in figure 3.2 and figure 3.3. Part 1. Measure h0, the height of the illuminated object as shown in figure 3.2, and measure hi, the height of the image on the screen as shown in figure 3.3. To do this is very simple. Again, we're just going to use the ruler. Just place your ruler accordingly from the top to the bottom, and I got a reading of 1.2. And as for the image, make sure to start at 0 centimeters until the tip here, which is at 4.8. Next, calculate a value of m for the magnification using this equation. So we're just going to substitute the values into this formula. So the magnification value of m would be 4. Next, part D. Calculate a value f1 for the focal length of the lens. Use your values from B part 2 and C part 2 and this equation. So f1 is equals to, the value of V1 obtained previously was 80 centimeters divided with m, which was 4, plus 1. So this will give us a focal length of 16 centimeters. Since you're looking for length, the unit measurement would be in centimeters. Next, part E. Describe one difficulty that is experienced when using a ruler to measure the height of the image in this experiment, and suggest an improvement to the apparatus to overcome this. To measure the image that is being projected on the screen, we're going to have to use a ruler. But the problem is that the object that is being reflected is obtained due to a light ray. And if we use a ruler, the ruler and our hand is going to get in the way of the screen due to shadow. By using a translucent screen, and we can measure the image from the back of the screen. Next, part F. The student adjusts the position of the lens so that u equals to 40 cm and obtains a new value for the distance between the lens and the screen, and this is the value given. Calculate a second value f2 for the focal length of the lens and use this equation. This type of questions are pretty simple because the formulas are always given and all you have to do is plug in your values. So f2 would be the value of u given multiplied by v2, which is 25.1, divided by u plus v2, which is 15.4 centimeters. Next, part G. Suggest which value of focal length f1 or f2 might be more accurate and explain your answer. f1 was being obtained from the first method, whereby we are using the value of v over the magnification plus 1. And the magnification was obtained by the height of object and image. Whereas in method 2, it was obtained by taking the measurement of u and v. So for me, I would say that method 1, which obtained f1, is more accurate because in the second method, smaller lengths are being measured and also the values of u and v is difficult to measure precisely. Therefore, this can increase uncertainty. Next, question 4. A student investigates the effect of insulation on the cooling of a liquid. This experiment is similar to the one that came out in variant 3 of May-June 2023. We are asked to plan an experiment which will enable to investigate how changing the thickness of insulation surrounding a beaker affects the rate of cooling of hot water in the beaker. So before planning the experiment, let's identify the key variables. I like to use the acronym IDC, I don't care, to help me remember which variable I'm looking for. So the independent variable here is what is being changed in the experiment, which is the thickness of the insulation surrounding the beaker. And the dependent variable here is the variable we're looking to measure or record. So we're going to measure or record the rate of cooling. Rate means the speed of a reaction. So to measure or record the rate, we're going to find the time, and since this is cooling, we're going to also record the temperature change. And lastly, the constant variable is what is to be kept the same so that this experiment is fair. We are using hot water, so we should ensure that the volume of the water that is being used is the same. And when we are measuring the change of temperature, we should always start with the same temperature. Okay, let's continue. The apparatus includes a glass beaker, supply of hot water, a lid to fit the beaker, and strips of insulation which can be cut to size. So when planning investigation, I like to answer according to bullet points. So the first bullet point here wants us to list any additional apparatus needed. This experiment requires us to measure time and temperature. We're going to need a stopwatch and a thermometer. Next, explain briefly how to do the experiment, including the measurements to take so that the rate of cooling can be determined. Now, when explaining briefly, so I have came up with this method called Monkey Really Rocks to help you remember what keywords you need to include in your second bullet point. The initial letter here is what we're going to use. M stands for measure, R, record, and another R is repeat. These are the keywords that you must have. We're going to measure the independent variable, record the dependent variable, and increase the independent variable. So we're going to measure the thickness of insulator and then record the time taken from a certain temperature until it drops down probably to room temperature. So we're going to record the time taken and initial and final temperature change. And then we're going to repeat the experiment for the different thickness of insulation. And when you repeat, you can say that for at least 4 other measurements. Okay, the next bullet point is to state the key variables to keep constant. When stating key variables for constant, I would always suggest you guys to mention 2 of them. And the two variables to keep constant here would be volume of water and the starting temperature. Next, draw a table or tables with column headings to show how to display the readings. You are not required to enter any readings in the table. So you're going to put your independent variable on one part of the table and your dependent variable. The dependent variable is measuring the change of temperatures and the time. And when writing a table, make sure to include the unit in every column. If you don't do this, you're not going to get a mark. And you can leave this part empty because no necessary reading will be required. And for the last bullet point, you are asked to explain how to use the readings to reach a conclusion. The answer is always pretty much standard. We're going to always plot a graph, and when you plot a graph, you have to mention what goes on the x-axis and what goes on the y-axis. How I like to remember what goes on the y-axis and what goes on the x-axis is drawing the letter D and I on the axis. So now I know that on the y it will be dependent, and on the x it will be independent variable. What goes on y-axis in this experiment is the rate of temperature change, and the independent variable is the thickness of the insulator. And now we're going to write all these bullet points into the answer space given in your paper. Alright, that's all for this video guys. Thank you so much for watching. For the next video, I'm going to discuss chemistry paper 6. If you like this video and you found it helpful, I would really appreciate it if you guys could subscribe to my channel. Thank you, bye!